And I realize I'm distorting a little when I'm talking because I'm wearing this lapel mic, and I guess I'm a loud talker. So moving right along, again, we're looking at using division. The difference is now the variable is negative. So whenever the variable is negative, and like we said, whenever you multiply or divide with a negative number, you're going to change the sign. And so that's exactly what we're looking at with these. So I'm gonna rewrite these, right? So we've got negative p over 7 is greater than negative 9. So again, we're going to multiply by a number, but we're going to multiply by negative 7 because that's you're dividing this. You attribute that negative sign to the denominator, and we're going to have to multiply by that because we not only want our denominator to have, or I'm sorry, our coefficient to be gone, but which means basically it's 1, but it has to be positive 1. So we have to get rid of that negative sign. So if we're multiplying by negative 7 on that side, we do the same thing over here. And then these go away, your negative signs go away, and you're left with p. And then remember, we're going to take this now and we're going to flip that thing around. All right, and its p is now less than 63. And so if I put 63 on the number line here, my answers for p are going to be anything that fall to the left of that number. See, I'm getting better with using this thing. Let's test it. So if p is less than 63, let's try a number that's divisible by 7 that is less than 63. So let's try 49. So it would be negative 49 over 7 has to be greater than negative 9. Well, negative 49 divided by 7 is 7, and then it would be negative. So it's negative 7 is greater than, or is not equal to, but greater than negative 9. Yeah, it is. So works out. We like that. We're starting to get the hang of this whole switching thing. So let's try another one. So got this situation here. So we're going to multiply now by negative 12 because we want to get rid of that negative sign as well as this 12 in the denominator. So we'll multiply this by negative 12 as well, because whatever you do to one side, you do to the other. And see, I just made a mistake here. I started to write it the same way, and you can't do that. So we're going to flip this, and then you have t is equal to 6 times negative 12, which is going to give you negative 72. So any values that are less than or equal to negative 72. So we're talking about very small numbers here, right? So let's try one that falls in that. And I'm going to pick something that's divisible by 12. Well, let's try negative 96. So if I put negative 96 in there, you've got negative, and you got a double negative here. So negative 96 over 12 is greater than or equal to 6. Well, 96 divided by 12 is 8. But it's going to be negative 8 because of this negative right here. And then you have a negative 8, which is positive 8. So works out nicely. 8 is greater than 6, definitely, so it falls in that range. So the reason this works, it's kind of weird, is because you're getting all these double negatives going on. So again, it's the same process of what you're used to with working with equations. The only difference is when the coefficient in front of your variable is negative and you need to get rid of it by multiplying or dividing by the same negative number, you have to turn that sign facing the other way. So you got to flip that sign. So that's the hardest part of this, is just remembering to do that. You remember to do that, you're in good shape.